Hey class, welcome back to our unit on similarity. We're going to get into similar polygons. And this will be the first of, again, 3 instructional videos on the lesson because there's a lot to cover and I talk a lot. So in this particular lesson, we're going over similar polygons. This is the whole thing. We're going to talk about using scale factors like what we covered in the previous video on ratios and proportions. We're going to talk about understanding similarity, using similar polygons, and using similarity. And today's lesson, we're really going to focus on understanding similarity and using it. Okay, so we have to begin with a note. This is a pretty cool note. So let's make sure we totally understand this before we move on. Otherwise, there's no use. So we can talk about any type of polygon, but 2 polygons are similar if. That word corresponding comes back. So we're talking about corresponding angles being congruent. The angles are congruent, yes, and the corresponding sides are proportional. So notice the difference. Corresponding sides are proportional. Okay, so the angles are congruent and the sides are proportional. So what does that mean? Similarity simply means same shape. Okay, similarity simply means same shape, not the same size. Same shape. Same size and same shape is congruent, right? But anyway, how does similarity work? Corresponding angles congruent, corresponding sides proportional. Okay, so in the case of the note, BC to HI is the same as BA to HG, is the same as AD to GJ, is the same as CD to IJ. Now, another interesting thing about proportionality is like what we covered in the previous lesson. So another thing, if we're talking about CD to AD, right? So if we did that, CD to AD, that would also be equal to IJ to GJ. Okay, so we need to keep in mind all the different types of equivalent proportions apply here. So we need to make sure that we understand that. That is the similarity note. We're going to use a bunch of that throughout the unit, but I figured I'd tell you now. So this is the note on similarity, right? So in this first video, we're just going to focus on that particular note. Okay, so let's talk about what's going on. So here's a note to make sure we understand what the heck just happened. We have these 2 triangles, triangle MNP blah, blah, and triangle SRT. Blah, blah. The question is, what are the pairs of congruent angles? Now, in order to answer this, we have to make sure we are understanding corresponding. Okay, so we have to understand corresponding. So if you remember that from previous units, let's be sure that we're doing that right now. So the way I like to deal with this is label stuff. Long, short, and medium. So clearly we can see that in the big triangle, I can just redraw it. In the big triangle, we have S, R, and T. In the big triangle, the long side is from T to R. Okay? So in the smaller triangle, what would be the long side? We want to draw the smaller triangle in a similar manner. Funny, similarity. If we draw the smaller triangle in a similar manner, we can see that the long side is from N to P, right? So we have N and P, but which one's which? It all depends on the short side, M and P there. So connecting the short side to the long side, we go from M to P. So therefore, we know that this part is P there, and this part is M here, which means this part is N here. So when we draw our triangles, we have to make sure that they are totally corresponding. And the way we can do that as well is use this to cheat. MNP, MNP, SRT, SRT. So we can make sure that everything is in the same order because that is corresponding. So now we can totally answer the question about congruent angles, right? So like the note said previously, corresponding angles are congruent, right? The corresponding angles are congruent. So we have to remember that for the note. So what are the pairs of congruent angles? Well, the corresponding angles are congruent. For example, angle T and angle P. Angle T would be congruent to angle P. Angle S would be congruent to angle M. And finally, angle R would be congruent to angle N. And so that's how we can understand similarity and how things correspond. Now, same diagram, different question. What is the extended proportion for the ratio of corresponding sides? Okay, now we're not doing the ratio of sides in each triangle because we can, like I showed you, but right now we're going to start by saying the ratio of corresponding sides. So again, we look at our diagram, right? So we take a look at the diagram. We can see we have a side, let's say TS. So we can talk about TS. TS would correspond to PM. So TS to PM would be equal to, let's say, SR and MN. We can do that. SR and MN. And that would be equal to RT and NP. Okay, so we're going in the same direction. Now, there's a bunch of different correct extended proportions, but when we're talking about extended proportion, we want to include all three sides. Okay, so this to this is equal to this to this is equal to this to this. Okay, so we're seeing, hopefully, proportionality. If any of this is confusing, you must go back to watch the previous videos. Okay, but if you understand this, you're right where you need to be. All right, so that is understanding similarity. Now let's throw a wrinkle in this bad boy. Let's take away the picture. Ooh, let's take away the picture. So now we have this, a four-sided figure, DEFG, is similar to, right? That's our symbol for similar, is similar to HJKL. What are the pairs of congruent angles? Well, remember how corresponding works. Without even drawing a picture, you can see that angle D would correspond to angle H. So angle D is congruent to angle H. You can see that angle E corresponds to angle J, so they are congruent, and angle F corresponds to angle K, they are congruent, and angle G corresponds to angle L, so they are congruent. Okay, angle L, funny looking. Anyhow, that's the pair of congruent angles. Now, question becomes, what if I told you about the question about sides? What about the extended proportion for sides? So I bet we can do that. So let's make an extended proportion for corresponding sides. Okay? So what are the sides? Without drawing a picture, clearly we know that side DE exists. And if side DE exists, so does HJ. And we can set up a proportion. Okay, so we're saying that DE to, well, we can set up a ratio anyway, to HJ is going to be equal to something else. Okay, now what would that something else be? What's another pair of corresponding sides? And so we look again at the coordinates here. We have EF and JK. Okay, so EF and JK are corresponding, so that would be our next ratio that is equal. Okay, so EF and JK. And that too would be equal to the third, right? The third side. What about KL and FG? Well, back the other way. So we have segment FG to segment KL. And that would be equal to a fourth side. Now, how do we know there's four sides? Because there's four coordinates. So what is that fourth side? Well, wrap it around, right? We can totally loop it around. GD and LH. Okay, so we can say that segment GD, a ratio with that with LH. That too would make our extended proportion. So we could use pictures or not pictures, and that is how we can understand similarity. So I'm gonna stop there for the first lesson to make sure that we totally understand that. So it's understanding similarity is what we've covered. Tune in, come back for more later.